All right, welcome back, everyone. I know it's been a while since my last post. We've been really busy in the lab recently, so I'm going to go ahead and do kind of a last review before we get into the new material starting on Monday. I hope you all have enjoyed your spring break. I know a lot of us certainly have. Although we won't be able to see you, it'll be good to get back into the swing of things. About a month and a half left here of school, if that. So we're really excited to see you guys via virtual interface. And I'm really excited to see how you guys have been studying. Hopefully these past videos have been helpful. I think this one's gonna be very helpful. It's more challenging material. We're gonna do acids, bases, pKa's, and pHs. So we're gonna go ahead and dive right in. Please feel free to stop the video at any time. I know sometimes I can go pretty fast through these problems because I know them very well. I've done them before. But please feel free to stop, quiz yourself. That's the best way to learn. You can watch me all you want, but that's not how it's going to be on the test. Obviously, you guys are going to have problems like this, but it's by yourself. So go ahead and even right now, stop the video and work through this first problem. You may notice this problem from somewhere. It may be a repeat. You've seen it before, but we're going to go ahead and do it anyways. It's a very good problem, and I feel like it'll be a good test prep as well. So it says at 25 degrees Celsius, lactic acid has a Ka of 1.4 times 10 raised to the negative fourth. What is its conjugate Kb? So we're given the conjugate. So we know lactic acid has to have the same chemical makeup as this. Let's go ahead and write out some sort of equation, right? We always want to start with some equation. So I'm going to write out lactic acid. And I know it's from this, right? Because this is the conjugate. So if I just add an H, that would make lactic acid. So we would have HC3, H5O3 plus H2O. Again, it's acid-base equilibrium, so we have the double arrows. You guys should be used to that by now. And then we have H3O plus and C3H5O3 minus. This is the first step to every problem. If you don't get this right away, you can still get the problem right, but it's going to be very challenging to see what's going on. For example, here I know this is lactic acid because it donates the proton to the water. So again, it's not necessary, but I would highly recommend you write out the overall reaction. So now let's look at 25 degrees Celsius, which that's pretty much meaningless. It's more just saying it's a standard temperature. We're given a Ka. Let's go ahead and write that down. Ka is equal, I'm going to write as a decimal. Right, 1.4 to the negative fourth as a decimal is just that, 3 zeros. So I need to find the Kb. So how would I find a Kb? I'm given Ka, how could I find a Kb? Is there any other term I know that would give me Kb? Well, we know that Kw is equal to Ka times Kb. We know this, and we know this. Kw, as you guys should know, is a constant. 1.00 times 10 raised to the negative 14th is equal to Ka. Again, I'm going to write this as a decimal. It makes it easier for me when I do the math, especially when I'm typing in my calculator. So all I would do is I would divide this over, and I would get Kb equal to 7.1 times 10 raised to the negative 11th. Okay, so that's my Kb. So now we should probably think, even though it's not asked, let's go ahead and think of a follow-up question. Is this conjugate base a strong or weaker base than the acetate ion? So let's think about that. So if we're looking at the acetate ion, we know the acetate ion comes from what acid? Acetate is closely linked with what acid that we've worked with before in Chem 110? Maybe acetic acid, right? If I have acetate and I just add the proton, it'd be acetic acid. So in this case, again, we would give you this on the test, but the Kb or the Ka for acetic acid is 1.8 times 10 raised to the negative fifth. So how do we get a Kb? Again, we're going to do the same thing. We're going to do Kw, 1.00 times 10 raised to the negative 14th is equal to 1.8 times 10 raised to the negative fifth times Kb. Again, divide it over, and we get a Kb equal to 5.6 times 10 raised to the negative 10th. So now let's compare x and y. Is x or y greater? Is negative 10 or a negative 11 greater? Negative 10, right? Because there's more decimals. So this would mean that this is a weaker base. Because when we look at bases and the strength of bases, we need to look at the Kb, right? We don't look at Ka on a base. A is for acid, B is for base. So looking at a Ka would be almost pointless here. So when you look at the Kb, in this case we have negative 11 and negative 10. This has more decimal places, so it's a smaller Kb, meaning a weaker acid. This is a larger Kb, meaning a stronger acid. A very elementary introductory question to start the night off. If you got this right, very good. If not, no worries. You might want to review Kw, Ka, and Kb. This will be a crucial concept for your exam coming up on April 2nd, which is less than a week from this video posting. So go ahead and review this if you didn't get it. If you did get it, very well done. We're going to move on to the next problem. And again, feel free to reach out to me via office hours, online, my email. I'm more than happy to answer questions about these. I may have made a mistake somewhere. I double check these to make sure I don't, but just to make sure, please reach out if you see anything or you have a question. So moving on, I'm given a 0.15 molar solution of an acid, and it has a pH of 2.8. What is the percent ionization and the Ka? Okay, very kind of in-depth question. So the first thing I should look at is the pH. pH is equal to 2.0. pH, P always in algebra, in any math class or chemistry class, P is equal to the negative log. Whenever you have a P, a small p, like you'll see it in pKa, you'll see it in pH, that just means negative log. So in this case, I have negative log of H+. What do I know about H+? It's acidic, right? H+ is that proton that we donate to be an acidic, whether it's a strong base, acidic, strong acid, or weak acid. So that H+ means we have the negative log of the acidic character. So let's do the pH 2.8 is equal to the negative log of H+, right? All I did was I subbed in 2.8 for the pH. How do I get rid of this log? This is where algebra comes in. If you know anything about logs, this is technically log base 10. So how would I isolate this 2.8 and this H+? This would go away, and I do 10 raised to the negative 2.8 is equal to H+. Whenever you need to get rid of a negative log, and you'll see this a lot in the next unit here, whenever you need to get rid of a negative log, just cancel it out and then raise whatever's on the other side to the negative. So 10 raised to the negative number. 10 raised to the negative 2.8. Yeah, that's just a logarithm function. You can look up the algebra in any textbook or online. This is a simplified version. I just remember the rule. Whenever I see log, I want to raise this side 10 to the negative number. So we're going to go ahead and run the numbers here. 10 raised to the negative 2.8 would be equal to 0.00158 molar. What is this the concentration of? H+. And what do we know about H+? H+ is my acidic character. So we have 0.00158 molar acid somewhere in this solution. Now let's look at what the problem's asking. What is the percent ionization? Percent ionization, I'm going to abbreviate percent I, is equal to moles ionized divided by moles available. Well, how many moles did I ionize? 0.00158 of my acidic character, right? It's an acid, so we're good to go. And what's my molarity of my solution? Well, it's given to us in the problem, 0.15. That's my moles available, right? Out of the 0.15 molar solution, I ionize 0.00158 molar H+. And it's an acid. H+ lines up with acid. We're good to go. You would multiply this by 100, because remember, this is a percent, so you should get 1.1%. Again, if you just ran the numbers here, you get 0.0011. Take it times 100, and you get 1.1%. So that is our percent ionization. But we're not done. We're looking for what is the Ka. Whenever you're asked what is the Ka, what is the Kb, you most likely are going to have to set up an ice table, which we know from equilibrium. We should be pros at it by now, so let's go ahead and try setting one up. Okay, what do I have on my reactants? A 0.15 molar solution of an acid. We don't know what acid, so we can just write HA, or you could write acid here. Either one will work. Plus water. Again, water doesn't do anything in equilibrium, so we're going to leave it out. What does an acid always associate? Well, acid, we know, donates a proton. So if this proton leaves, it has to go to this side. And what's left? If this proton, if you cross out this H, what's left? A minus, right? You can go back to my first video as well if you don't understand how I got the plus and the minus. Again, we're at zero charge here. If we lose a proton, A minus. Good. And we're given the starting molarity is 0.150. What would these two values be? 0. We're not given any products to start, right? We are ionizing this solution of the acid in water. So we'd have 0.15 molar, the starting molarity, and we have no products. What is my stoichiometric coefficient on each of these? 1, 1, and 1. So minus x plus x plus x. We're talking about stoichiometry. The reason why it's minus x, because again, this side has to be negative, because if this side was negative, we would go in, or if this side was a minus x, we would go into a negative concentration, which doesn't exist. So in this case, you would have 0.15 minus x, x, and x. So now what are we asked to find? The Ka. Well, Ka, just like Kc, just like Kp, just like Q, is what over what? Ka is equal to products over reactants. Well, here's where I'm stuck, because I don't have a K, and I have equilibrium, but it's in terms of X. So I'm screwed, right? No, that's where you're wrong. You have the information you need. Look what we solved for here. H plus is equal to 0.00158. H plus. Well, H plus started at 0 and it changed to 0.00158. So X is equal to 0.00158, right? I just got that from here. So if that X is 0.00158, this X has to be 0.00158, and this X has to be 0.00158, right? It's all the same X. It's just a placeholder for a number, and that's, in this case, it's that number. So let's go ahead and set up our ice table. What goes on the top? Products. H plus, we know is 0.00158 times A minus, which is also 0.00158. What goes on the bottom? Again, equilibrium, you guys should be masters of this. 0.15 minus my X. Now I can solve for Ka by running the numbers. No solver is needed. You can run the numbers, and you should get a Ka of 0.1234017, or 1.7 times 10 raised to the negative 5th. So to recap, we did percent ionization by doing simple logarithmic functions to solve for a concentration of H+, because that's all pH is. P negative log of H+. Percent ionization, done. From this percent ionization, step 1, we got a molarity of H+, which we found out to be our X value in the ice table. When you're doing basic acid-base kind of problems like this, where you're finding a Ka, you're most likely going to have this kind of scenario. We're doing an ice table, you have an acid going to a conjugate in H+, and more likely than not, with stoichiometry, your X is going to work out to be this value. You might see that in your homework. You might see that in your book. Also, recitation problems may have this as well. Very good problems to look at. But it's kind of the same format each time you do it. All right, go ahead, and we're going to move on to the next problem. This one's tough. This one's really tough, I think. So if you can pause the video now and solve this by yourself, you're doing pretty good for acid and base chemistry. This is probably as hard as it gets for what we're learning up to now. So we have pyridine, C5H5N, has a pKb of 8.77. What is the pH of a 0.2 molar aqueous solution? What's the first thing I should do before doing any math, before writing any ice tables? The first thing I should always do for the rest of the semester on any problem is write a chemical equation. This should actually, pyridine is C6. That's my bad. So we have C6H5N plus H2O. We know pyridine is a base because it has a pKb given. A base does what with a proton? Does it receive it or does it donate? A Bronsted base receives the proton. So the H goes from here to here, right? H2O is the donator. So we have HC6H5N plus OH minus. Remember, this lost a proton, so it becomes OH minus. Good. So we have our chemical equation. We have a pKb, and we're given a molarity. Well, in the last problem, according to what I just told you, everything's the same kind of scenario. We started with the pK, or the pH, to start. So let's start with that. If it's the same scenario, and I'm not lying to you, which I hope I'm not, we start with pKb. So we have a pKb of 8.77. What does P stand for? Negative log. So the negative log of my Kb is equal to 8.77. How do I get rid of a negative log? Cross it out, raise the other side from 10. Just like the last problem. 10 raised to the negative 8.77. It's kind of looking familiar. This is just a number. I would run the numbers and I get 1.70 times 10 raised to the negative 9th is equal to Kb. Look at that. It's the same exact process. It's just flipped. It's the same exact math. So now what do you think we're going to have to do? We're given a starting molarity. If the process is the same, I'm not lying to you, 0.2 molar, last time we had 0.15 molar, what do we do with that molarity? We threw it in an ice table. Let's throw it in an ice table and see what happens. What's the only difference here? Do I start off with an acid or a base? A base. So I'm just going to write a base is in equilibrium with, again, there's H2O over here, but H2O doesn't do anything in equilibrium. We're going to go with my acid and OH minus, right? Acid, OH minus, base. Same thing. I just abbreviated for simpler terms and it saves some room. Again, I get lazy. So it's Friday night. 0.20 is my starting concentration, right? This was given to us in the problem. 0.20 molar aqueous solution. What do these have to be? 0, right? We're not given any product to start. This is not a titration or something where we're halfway. So we know those are 0. Stoichiometry is 1 everywhere. We can't go negative on the right. Carry it down. It's the same exact process. But what's different this time is we have a Kb now. Last time we solved for the K, this time we have a K. And we know K is what over what? Products over reactants. So my K, 1.70 times 10 raised to the negative 9th is equal to my products, X, 0.2 minus X. Now here's where you're going to use the solver function to solve for X. Go ahead, even if you're way ahead, stop the video, double check, and solve for x again. You can do it by hand. This one's pretty easy by hand. Double check for x, pause the video. All right. X is equal to 0.000018 or 1.8 times 10 raised to the negative fifth as exponential form. So we need to find the pH. Well, we know what about pH? pH is just equal to the negative log of H plus. Well, dang, we're screwed here because we don't have H plus. So now I give up. Probably not. Never give up. Find something. Find a way. There's multiple ways to do this. Find a way. Again, pause the video. Find a way to get to your pH. So if you're stuck, what do we know about pH and pOH? pH plus pOH is equal to 14. So I could just do pH is equal to 14 minus pOH. Well, I can get my pOH, right? Because I have a concentration of OH minus. My concentration of OH minus just tends to be X. It just somehow happened that it worked out to be X. And we already solved for X. So let's plug in numbers. pH is equal to 14 minus the negative log of 0.00018 or 1.8 times 10 raised to the negative fifth. If you work out the numbers, the pOH would come out to 4.73. So 14 minus this would give you a pH of 9.27. If you finish with this before I finished, very well done. This is kind of one of those all-encompassing problems. Write out the equation, find the KB, throw it in an ice table, solve for X using solver, then think about how you convert pH and pOH together and why that's important because we only have an OH minus, not an H plus. Very good problem to know for your upcoming exam. There's going to be something similar like it. It will obviously won't be the same exact problem, but there's going to be a problem if you think about pH, pOH, pKb, pKa, stuff like that. You're going to have to know this. If it's challenging, please stop the video, rewind it, and rework the problem without my help. It's a great way to test yourself, is doing something by yourself without someone else's help and no answer key. All right, then my last problem for the night is kind of a multiple choice. There is some math, but it's not as in-depth as the last two. So we are given 0.14 molar NH4CN. Don't know what that is. Ammonium, don't even know. Have a basic, acidic, or neutral pH. So we're given a molarity of something, and we need to find if it's basic, acidic, or neutral. Interesting. How would we start? Well, we have to think. Since the ammonium ion is the salt of a weak base, I'm getting ammonium because NH4CN, we would have NH3, right? NH4CN and H2O would go to NH3 plus HCN. What do we know about HCN? It's an acid, right? H. There's an H plus and a CN minus. If there's an H plus to give away, that means it's an acid or has acidic character. Is this one of your 7 strong acids from Chem 109? It is not. It is a weak acid. You can look at the P, or you can look at the Ka. We're not going to solve for that because technically it's supposed to be given to you on the test. We don't expect you guys to memorize Kas. But again, HCN is a weak acid. So if the Ka of NH4 plus, again, these would be given to you on the test. We do not expect you to know these. You can look them up when you're doing the homework or book problems. The Ka here is equal to 5.6 times 10 raised to the negative 10. Okay, so the Ka is 5.6 times 10 raised to the negative 10th. Well, we need the Ka of NH4 plus. We're good there. If you wanted to, you could also run the Kb. It will flip the problem, but you still get the same answer. Let's go ahead and do it for those of you that ran a Kb. So how would I solve for Kb? Again, use Kw. 1.00 times 10 raised to the negative 14th is equal to 5.6 times 10 raised to the negative 10 times Kb. Kb is equal to 1.8 times 10 raised to the negative 5th. If you ran the Kb, it's good, but we need to look at Ka, and I'll explain why when I get to the second part. So now if we know the NH4 plus, which is right here, remember this is like two constituents. We have NH4 plus and Cn minus. When you look at a chemical equation, we can go back to this one. NH4 plus, in this case, the plus was the acid, right? The ion, no other ion here has a plus except this one, and this one has the H. This is my acid, making this my base, or basic character. So let's apply that to this rule. If my NH4 is my acid, that leaves Cn to be my base. So I need a Ka here and a Kb here. Double checking our work, we ran a Ka for NH4 plus. We're good to go. I need a Kb for Cn minus. Kw is equal to Ka times Kb. 1.00 times 10 raised to the negative 14th is equal to, and we would give you the Ka here. In this case, it's 4.9 times 10 raised to the negative 10th times Kb. Divide this over, and you get a Kb of 2.0 times 10 raised to the negative 5th. So this is my Ka, this is my Kb for Cn minus. So now we look at what the question's asking. Does a 0.14 molar NH4Cn solution have a basic, acidic, or neutral pH? How can we make that decision? We don't have any concentration of H+. We don't have a pKa. This is tough. This is where students will start giving up. But what do we notice? The Kb of Cn minus is larger than the Ka of the NH4, right? Again, the Kb right here, 2.0 times 10 negative 5th, is much larger than the Ka. NH4, NH4, Cn, Cn. If the Kb is larger than the Ka, does that mean it's acidic or basic? Kb is larger than Ka. Rewriting this, base is larger than acid. If base is larger than acid, what do you think it's going to be? It better be basic or we're screwed. The answer would be basic. Again, you have to think. I didn't have an H plus here. I didn't have any OH minus. So I can't directly get a pH or a pOH, which that would help us solve the problem immensely because we need to see if it's basic, acidic, or neutral. Well, if we have a pH, then we can just go on the number line and look. But in this case, we weren't given a pH. We were given a Ka and a Kb. We have to make a decision from there. Very, very tough problem. You have to think kind of outside the box. So that is it. I hope you guys are enjoying the videos. I know I've been seeing a lot of views in the past week here, so I think that's a good thing. Some good comments. Some of you guys subscribed. Thank you. It's not necessary, but I appreciate it. I really hope these are helpful to your learning. I hope this supplements what you're doing. Again, this shouldn't be the only thing that you're doing to study. If this is all you're doing to study, you might be behind by a lot, like a lot. Given that this is online and we just came out of spring break, personally, what I think you should do for multiple choice, again, it's very similar format to your previous tests. What I would do for multiple choice is read the book. And don't read it just to read it like it's a history textbook. Look at the figures. The textbook is very dense. It's very dry at sometimes. Just read the figures and the captions. Sometimes there are questions that are directly related to those figures and captions. If you don't understand the figures, read the text below the figure. Then you might understand it. For short answer, do these videos. Do your recitation TA problems. Do the SI problems. Watch the lectures online. They're not mandatory technically, but you should be going to lecture online and attending. Do those problems. Stop the video when Dr. Kaus is presenting and see if you can work the problems before he gets the answer. And that's a good test of where you're at. Again, feel free to reach out to me. I'm here for your guys' learning. I really want you guys to do well on this next test. I want you guys to do well in Chem 110, especially all the other TAs, even lab TAs, SI TAs, Resi TAs. We want you guys to do well. We want to see you guys get the grade that you deserve. So please feel free to reach out. Again, this is the end of my video tonight. I will be sure to post next week as well. I hope you guys enjoy the rest of your weekend. Stay safe and have a great night.